This is Foundational Mathematics for Secondary School Beginner Level. This course is facilitated by Limitless Learning TT, where it's all about learning on the go. Log into our website from any place at any time and view past videos, practice problems, and solutions for your course. For more information on the services we offer, you can visit our website at www.limitlesslearningtt.com. If you have any additional questions or concerns, please feel free to send us an email at info@limitlesslearningtt.com. In this lesson, we're going to be doing a recap of the types of numbers. We're also going to do a recap of negative numbers as well as a recap of fractions. These are all topics that we would have completed in the previous course, which is Introduction for Mathematics, both beginner and intermediate level. So we're doing a recap just to make sure that that foundation is in place. So let's start with our types of numbers. Thus far, we would have encountered the first four types, which are natural numbers. So natural numbers are counting numbers, basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, onwards to infinity. Those are counting numbers. Our whole numbers are different from natural numbers, whereas we've now added 0 to our natural numbers. So our natural numbers start at 1, 1, 2, 3, 4, 5, and so forth. When we talk about whole numbers now, we add 0 into the mix. So our whole numbers are different from natural numbers. Now, all natural numbers are whole numbers, but not all whole numbers are natural numbers, because if I pick 0, which is a whole number, it's not a natural number. Now, integers basically are whole numbers and their opposites, or it is the addition of negative numbers into your type of numbers. So now we have -1, -2, and so forth, -3, -4, all the way down to -infinity. So that encompasses our integers, which are basically positive and negative numbers, inclusive of the number 0. Then the next type of number that we would have seen was rational numbers. Rational numbers are any number that can be expressed as the fraction of two integers. So rational numbers kind of fill in the spaces in between these integers. So for example, 1/2 is a rational number because we used two integers, the number 1 and the number 2, to come up with a new number, which is a rational number. -1/2 is also a rational number because we would have used two integers, -1 and the number 2, to come up with that rational number. So rational numbers are like fractions. Basically, once you can express it in a fraction form, it's a rational number. The number 2, which is a whole number as well as a natural number and an integer, can also be a rational number because 2 is the same thing as 2 over 1. So because I'm able to express the number 2 in the form of a fraction with two integers, it means that it's also a rational number. So it's as though we started with one set of numbers, and every time we discovered a new number, it would add to the amount of numbers that we had. So we started off with just counting 1, 2, 3, 4, 5. Then we added 0 into the mix. Then we added negative numbers. Now we're adding fractions in between there. Right? And then the new type of number that we introduced to in this course would be irrational numbers. Now you just need to know what an irrational number is, but you're actually not really going to bounce up irrational numbers unless you're taking additional mathematics for the CSEC level, or if you're on the tertiary level of math, right? It's not something that you will bounce up, but it's good to know what an irrational number is. And an irrational number is a number that cannot be expressed as a ratio between two integers. So an example of an irrational number would be the square root of 2. There is no exact number that encompasses the square root of 2. Another example of an irrational number is pi. That's something that we see all the time. And I know you're probably thinking, well, I know pi to be 22 over 7, or I know pi to be 3.142. Those values that they would have given you for pi are approximated values. So because there is no actual number that defines pi, they tell you, okay, use 22 over 7 as an approximation of pi, or use 3.14 or 3.142 as an approximation of pi. But pi and the square root of 2 are two examples of irrational numbers, as in you cannot find two numbers that you can put as a fraction that is going to give you pi or is going to give you the square root of 2. So that's it for the type of numbers that we would have focused on thus far. Now, what I wanted to do is just do a quick recap of adding and subtraction when it comes to negative numbers, because it's something that we're going to bounce up a little bit later when we are in the algebra section. And I also wanted to do a recap of fractions, because that's something that we're also going to see again when we get into the algebra section, and I just want to make sure that that foundation is pretty much strong. So when we're talking about integers, we're talking about positive and negative numbers. And the example that I always use to kind of explain how positive and negative integers work using this idea of a box, balloons, and weights. So I have a box with balloons, and the squiggly things on the bottom are weights. Okay, and what you're going to think of is you're going to let your weights represent negative numbers. So anytime we talk about weights, essentially we're talking about negative numbers. And then when we talk about the balloons on the top, it's as though we're equating balloons to be positive numbers. So our balloons are the same thing as positive numbers. So when you hear me talk about the balloons, is as though I'm talking about positive numbers, and when I talk about weights, is as though I'm talking about negative numbers. So when we're adding positive numbers, that's 1, 2, 3, 4, 5, and so forth, right? When we're adding positive numbers, is as though we add balloons. If you have more balloons or you add balloons to the mix, it's going to cause this box to rise. So the more balloons that you put, or the more balloons that you attach to this box, the more the box is going to rise, or you think of rising as the box getting larger. So when you add balloons, which is the same thing as adding a positive number. So when you add balloons or a positive number, the box gets pulled upwards, which means that you get larger. So when you add a positive number, you get larger. The amount or the result is going to be larger than what you started off with. What if you take away balloons? If you take away balloons from your mix, that's like now we only have 2 balloons. If we only have 2 balloons now, it means that our box is going to get pulled downwards. If our box gets pulled downwards, it means that we're getting smaller. So when we take away or we subtract balloons, which is like subtracting a positive number, we're going to get pulled downwards. Once we get pulled downwards, we're going to get smaller. So moving downwards means we're getting smaller. Moving upward, means we're getting larger. So we take away balloons, means we take away a positive number, we get smaller. Our result is smaller. What about when we're talking about our weights, which are negative numbers? So the more weights I add to this box is the heavier the box becomes. So the more weights I add is the heavier that it becomes, and it gets pulled downwards. So when I add weights, which means I'm adding a negative number. So when I add a negative number, I get smaller because I get pulled down, right? So once I add negative numbers or I add weights, my box is going to get heavier, it's going to be pulled downwards, and it's going to get smaller. So when we add a negative number, we get smaller. What about when we subtract our weights? Well, if I take away majority of these weights, let's say I only have 2, it means that I'm making my box lighter, which means that my box is going to move upwards. So therefore, when I subtract weights, which is the same thing as taking away negative numbers. So when I subtract weights, it's the same thing as subtracting negative number. So when I subtract a negative number, I am going to get larger. Okay, so hopefully you kind of get that analogy, which is why when we are adding a negative number, this sign changes to a negative sign, right? Because you're getting smaller. But when you subtract a negative number, this results with a positive sign because you get larger. So when you see add and negative come together, you get smaller, you become a negative sign. When you see 2 negative signs come together, it means that it's positive, it gets larger. So that's just kind of the concept with adding and subtracting negative numbers, and understanding how it works with respect to this analogy of your balloons being positive numbers and your weights being negative numbers, and seeing the direction that the box moves, indicating whether it gets larger or whether it gets smaller. Now again, what I'll do is at the end of each video usually has a set of practice problems and corresponding solutions. So there'll be lots of questions with positive and negative signs, just so that you can kind of get yourself refreshed with the material. So what I want to do now is move on to a recap of fractions, and then once we have time at the end, we'll kind of do a general couple of examples on the material that we would have covered in this lesson. So I want to talk about fractions. When we're dealing with fractions, we have 2 types of fractions. The first is an improper fraction, and the second is a proper fraction. So fraction is usually a ratio of a first number to a second number. The number on top is known as your numerator. I've just added a letter as a placeholder. The number on the bottom is known as your denominator. Right? If your numerator, right, is smaller than your denominator, then we're talking about a proper fraction, right? So this is known as a proper fraction. And examples of these will be like 1/2, 3/8, 5/11, maybe 1/18, right? So the number on the top is smaller than the number on the bottom, proper fraction. If instead our numerator is larger than our denominator, So if we have a numerator is larger than our denominator, then this is known as an improper fraction. Right, so an example of this will be 4 over 1, 5 over 2, 101 over 71. Any number where the number on top, which is your numerator, is less than your number below, which is your denominator, is known as an improper fraction. So we have proper fractions and improper fractions. And then we also have something that's known as a mixed number. And a mixed number is made up of an integer as well as a proper fraction. So mixed number has a integer, and a proper fraction. And this is a mixed number. Again, I'm pretty sure you are familiar with this. So 1 and 1/2, a mixed number. 4 and 17 over 21, mixed number, right? Negative 4 and 1/7, also a mixed number, right? So once you have an integer as well as an accompanying proper fraction, this is known as a mixed number. Now, when we're talking about fractions, we always want to know how the 4 operations will affect fractions. So 4 operations being addition, subtraction, multiplication, and division. So when we're talking about fractions, we're going to learn how to do addition of fractions, subtraction of fractions, multiplying fractions, and dividing by a fraction. So let's start with the first, which is the addition of 2 fractions. So there are 2 different ways that can determine how you're going to add your fractions. Now, the first thing you want to do is look at the denominators of the 2 fractions that you want to add. If those denominators are the same, then you just add across the numerator. So this is the first option. So if my denominators are the same, I'm going to just add the numerators. So for example, let's say I had 3 over 25 plus 11 over 25. Now, in both of my fractions, my denominator is 25. So the first fraction, my denominator is 25. Second fraction, my denominator is 25. So that's great. I'm going to leave my denominator as 25, and I'm going to add my numerator. So that's 3 plus 11. And 3 plus 11 is 14. That's 14 over 25. Again, another example, if I had 12 over 34 plus 7 over 34, again, I look at my 2 denominators. They're both the same. That's great. I'm going to leave the denominator as is, and I'm going to add my numerators. So that's 12 plus 7, and 12 plus 7 is 19 over 34. So very simple for adding fractions if the denominators are the same. What happens if the denominators aren't the same? So if my denominators are not the same, I'm going to find the LCM. That's my lowest common multiple for the denominators that I'm given. Then I'm going to convert each original fraction to a fraction that uses this LCM. And then I'm going to be able to add the numerators. So it sounds a little bit complicated. It really isn't. Let's look at an example. Suppose I had 1/2 plus 1 over 4. Right, I'm looking at my denominators, 2 and 4. They're not the same. So I need to find the LCM of 2 and 4. When we're talking about multiples, we're talking about multiples of 2 would be 2, 4, 6, 8, etc. So I'm looking at multiples of 2. This is going to be 2, 4, 6, 8, 12, and so forth. Oh, 10, 12, and so forth. And then I'm going to look at multiples of 4. Multiples of 4 would be 4, 8, 12, 16, and so forth. So I'm looking at these set of multiples, and I'm looking for the lowest number that they have in common. Well, that's going to be 4. So the lowest number that they have in common is 4. So therefore, I need to change these two fractions so that their denominator is 4. Well, this one, the denominator is already 4, so I don't need to change that. But I do need to change 1/2. So 1/2, I want to write it as something over 4. What do I have to multiply 2 by on my denominator to get 4? Well, 2 by 2 gives me 4, so therefore I'm also going to multiply my numerator by 2. 1 times 2 gives me 2. So 1/2, written in terms of my new denominator, which is the LCM, which is 4, is 2 over 4. So my original question, which was 1/2 plus 1/4, is now the same thing as 1/2 is 2 over 4, and 1/4 is already in terms of 4 in the denominator. So now I'm back to my first rule where my denominators are now the same. It's 4. So I can simply add the numerators. So this becomes 2 plus 1 over 4, and 2 plus 1 is 3. That's 3 over 4. Let's look at another example. So I now have 2/3 plus 1/4. Okay, now I am going to look at my denominators. They're clearly not the same, so I need to find the LCM. So I'm looking for multiples of 3 and multiples of 4. So my multiples of 3 would be 3, 6, 9, 12, 15, and so forth. And my multiples of 4 will be 4, 8, 12, 16, 20, and so forth. And I'm looking for the lowest number that is in common between these two, and that's going to be 12. There's nothing that's smaller than 12 that's in common. So my LCM is going to be equal to 12. So now I have to change 2/3 into something that has 12 on my denominator, and I need to change 1/4 into something that has 12 as the denominator. So I'll start with 2/3. In my denominator, I have 3. What did I have to multiply 3 by in order to get 12? 4. So I'm also going to multiply my numerator by 4, and 2 times 4 is 8. So 2/3 is the same thing as 8 over 12. I'm moving to 1/4. What do I have to multiply 4 by in order to get 12? 3. So 4 times 3 gives me 12 on my denominator. So I multiply by 3 on my numerator, and that gives me 3 over 12. So 1/4 is the same thing as 3 over 12. So my original question, which was 2/3 plus 1/4, is now the same thing as 8 over 12 plus 3 over 12. And now that my denominators are the same, they're both 12, I can simply add my numerators. So that's 8 plus 3 over 12, and 8 plus 3 is 11, so that's 11 over 12. So my final answer is 11 over 12. So addition of fractions, you really want the denominator to be the same because you can just add the numerators. If not, then you find the LCM, you make the denominators the same, and then you add across the numerators. Now the good thing is when it comes to subtraction of fractions, the rules are basically the same. You want the denominators to be same. If they are, you can just subtract the numerators, and if they're not the same, then you find the LCM, you convert the fraction to one that uses the same LCM, and then you subtract the numerators. So let's look at the subtraction of fractions. So now I have amended my rules so that it mimics for subtraction of fractions. So for example, let's say we have 15 over 47 minus 2 over 47. Well, I look at my denominators. My denominators are the same. Life is great. I leave my denominator as is, 47, and I simply subtract the numerators. So that's 15 minus 2, and 15 minus 2 is 13. So that's 13 over 47 is my answer. Great. What happens if now my denominators are not the same? Well, again, it's the same procedure as addition. So instead, we're going to do 2/3 minus a quarter. So I'm looking at my first denominator, it's 3. My second denominator, it's 4. They're not the same. I find the LCM. So I'm looking for multiples of 3 versus multiples of 4. And my multiples of 3 are 3, 6, 9, 12, 15, and so forth. And my multiples of 4 are 4, 8, 12, 16, 20, and so forth. And I'm looking for the smallest number that is in common between both of these, and that will be 12. So it means that my LCM is going to be equal to 12. Now I need to change 2/3 into something where 12 again is my denominator, and then the same thing, I need to change 1/4 into something where 12 is my denominator. So just like the one we did before, 3 times 4 will give me 12 in my denominator. So I also multiply my numerator by 4. That gives me 8 over 12. And then 4 times 3 gives me 12. So I multiply my numerator by 3. So this is 1 times 3 is 3. That's 3 over 12. And my original question was 2/3 minus 1/4. So this is now 8 over 12, because that's the same thing as 2/3, minus 3 over 12, which is the same thing as 1/4. And I simply leave my denominator because it's now the same. They're 12. And I subtract my numerator. So that is 8 minus 3 is going to give me 5. My answer is 5 over 12. So addition of fractions, subtraction of fractions, basically the same rules. You want your denominators to be the same. If they are, you add or you subtract the numerators. And then if they're not the same, you find the LCM. You convert the fraction to the new LCM as that denominator. And then now your denominators will be the same, and you simply add or subtract the numerators. So that covers addition of fractions and subtraction of fractions. What if we're talking about the multiplication of fractions? So when we come to the multiplication of fractions, basically there are 2 options that we can do. The steps are all the same, but we can just put it in another order. So the first option is we multiply the numerators, then we multiply the denominators, and then we simplify the fraction if it's possible to do so. With option 2, we try and simplify the fractions first, if possible, which involves like canceling numerators with denominators. Then we multiply the numerators, then we multiply the denominators, and then we get a final answer. And because we would have simplified first, there's no need to simplify any further. So let's look at 2 questions. Well, the same question, using different options. Okay, let's say we have 5 over 12 multiplied by 2 over 15. Using option 1, we would multiply the numerator, so that's 5 by 2, and then we multiply the denominators, that's 12 by 15. So 5 by 2 is easy, it's going to give us 10. 12 by 15, you can plug it in your calculators, or you can do it the long way, basically, which is like 15 by 12. And you add a 0, 5, 1. The answer is 180, by the way. 2 times 5. 2 times 5 is going to give you 10. And we put that little 10 on the outside. And then you do 2 times 1, which is 2, plus this 1 is 3. And your answer is 180. You add these together. Multiplication, something you should be familiar with. If you did that before as in this long multiplication or multiplying for large numbers, should be familiar with it. If not, punch it in your calculator. That always works as to recheck your answer. So on the bottom you have 180. So you have 10 over 180. And what you can do is you can simplify this further by finding a number that's common between 10 and 180, and that number is 10. So 10 divided by 10 will give you 1, and then 180 divided by 10 will give you 18. So your answer is 1 over 18. Option 1, right? Multiply numerators, multiply denominators, and then when you get down to the end, simplify the fraction if you can. What if we did it the other option, which is option number 2? You want to simplify the fraction first if possible, and then multiply numerators, then multiply denominators. So in this case we have 5 over 12 multiplied by our 2 over 15, the original question. And what we do when we're simplifying our fractions that we're multiplying, we're looking for things that are common between numerators and denominators. It could be the numerator of the other fraction with the denominator of the other fraction. It doesn't have to be same numerator and same denominator of the fraction. So I can look at 2 and 12, right? So I'm looking at this number 2. This number 2 here, and this number 12. And 2 and 12 are both even numbers, which means that they can divide by 2. So 2 divided by 2 is 1, and 2 divided by 12 is 6. Okay, this is me looking for things that are in common between numerators and denominators. It's always between numerators and denominators. Then I can look at this 5 here and 15. They are both divisible by 5. So 5 divided by 5 is 1, and 5 divided by 15 is 3. Now I can't simplify any further because on my numerators I have 1, and my denominators I have 2 other numbers, so I can't get any smaller than the number 1, which is in the numerators for both of my fractions. So I've simplified as much as I can do, and now I'm going to multiply my new numerators, which will be 1 times 1, and my new denominators, which will be 6 times 3. 1 by 1 is 1, and 6 times 3 is 18. So you see, I get the same answer. So a different method by just switching around the order of the steps. But again, it gives me the same answer. Sometimes it's easier to just multiply the numerators, multiply the denominators, and then cancel. Other times it's easier to cancel and simplify first and reduce how big the numbers are to something that's small and easier to work with, and then you multiply across. So you kind of get rid of that having to multiply by 12, by 15 in the first option, than it moving to be 6 by 3, which is a lot easier to multiply in the grand scheme of things. Now, when we're doing division of fractions, it's as though we're doing the same thing, kind of, with one little step in the beginning. So I'm going to leave multiplication of fractions up here. I'm going to put the rules for division of fractions right under, so you can see it's basically kind of the same method with one little extra step added in. So for the division of fractions, what changes is the first step. What you're going to do is turn the second fraction upside down, which is known as the reciprocal, and then you're going to replace the division sign with a multiplication sign. And then now that you've changed it into like a multiplication question, it follows that you can either do option 1 or option 2. Now again, all of this doesn't make sense unless you kind of see an example. So our question is 4/7 divided by 5 over 21. Now our first step is we want to flip the second fraction. So this is the second fraction we're talking about here, 5 over 21. So what happens is your numerator becomes a denominator and denominator becomes a numerator. That's known as the reciprocal. So you're flipping it or turning it upside down. So it now becomes 21 over 5. And you're changing your division sign to a multiplication sign, and your first fraction remains unchanged. So you now have 4 over 7 multiplied by 21 over 5. That's this step that you would have just done, right? You turn the second fraction upside down or found the reciprocal, and then you replace the division sign with a multiplication sign. Now that you've done that, this is a straight multiplication question, and you can do option number 1, which would be 4 times 21 over 7 times 5. Right, and then you multiply 4 by 21, which is, what's that, 84? And then 7 times 5, which is 35. And then what you can do is look for a number that's common to both of them. And 7 is in common with both of them. So I'm actually going to place the actual answer on top. So 84, you know what? Let's not do that. 84 and 35 both have 7 in common. So 84 divided by 7 is 12. And 35 divided by 7 is 5. So your answer should be 12 over 5. So answer, this is 12 over 5. Right, so now I can just erase this answer, and now I'm going to do it the same way using option 2. You get the same answer, right? So again, before you even get to option 2, you have to do that first step, which is you had originally had 4 over 7 divided by 5 over 21. So that first step would be to switch your fraction or make it upside down, aka the reciprocal. The denominator becomes the numerator and your numerator becomes the denominator. You switch the division sign for a multiplication sign, and then you will put back your original fraction, first fraction as it was, which is 4 over 7. And then using option 2, what you're doing is you're going to simplify your fraction first. So 7 and 21 are in common. They can both be divided by 7. So 7 divided by 7 is 1. And 21 divided by 7 is 3. I cannot simplify any further because 4 and 5 don't have anything in common with each other, and 3 and 5 don't have anything in common with each other. So now I multiply my numerators, which is 4 times 3, and my denominators, which is now 1, right, times 5. 4 times 3 is 12, and 1 times 5 is 5. So you get the same answer, 12 over 5. So again, addition and subtraction, basically the same rules, okay? The only difference is whether you're adding or subtracting. Multiplication and division, kind of the same rules, except for division. You have to turn your division into a multiplication question, and that's by finding the reciprocal of the second fraction and then changing that division to a multiplication sign. Simple enough. We would hope so. Now that we've done a recap of our positive and negative numbers in terms of addition, and we've kind of done a recap of our fractions with respect to the operations addition, subtraction, multiplication, and division. What we'll do now is a couple of practice problems just to kind of tie up everything that we would have done and everything that we would have mentioned in the lesson. So just to do a quick recap, when we're talking about positive and negative numbers, When we add positive numbers, we get larger. When we subtract positive numbers, we get smaller. When we add negative numbers, we get smaller. And then when we subtract negative numbers, we get larger. And that's evident because when we have a positive and a negative number coming together with addition and subtraction, that sign becomes a negative sign. And then when we have two negative numbers coming together, it becomes a positive sign. And I don't know if I mentioned it or not, when it comes to multiplying and dividing numbers, if you have two positive numbers, your result is positive. If you have one positive number and one negative number, your result is negative. And if you have two negative numbers, then your result is positive. So it's the same kind of concept that we're using here. And then, well, we already did our recap of fractions. So let's look at some practice problems. So my first question is going to be 4/7 plus 2/6. I'm doing addition of fractions. My denominators are not the same. I need to find the LCM. Now I'm going to look at multiples of 7 and then multiples of 6. So my multiples of 7 will be 7, 14, 21, 28, 35, 42. And for 6, multiples of 6, 6, 12, 18, 24, 30, 36, 42. So the smallest number that's in common between both of them is 42. So my LCM is going to be equal to 42. Now I have to change 4/7 and 2/6 into something where my denominator is 42 for both of them. Looking at the first one, if I multiply 7 by 6, I get 42. So I'm going to multiply my numerator by 6 as well. So 4 times 6 is going to give me 24. Then I'm looking at my second fraction. If I multiply 6 by 7, I will get 42. So I also multiply my numerator by 7. And 2 times 7 is 14. So my original equation, which was 4/7 plus 2/6, is now going to be equal to 4/7 is 24/42 plus 2/6 is 14/42. And because now my denominators are the same, I can leave my denominators as 42 and add my numerators, which is 24 plus 14. And that's going to give me 38/42. Now, if you wanted to, you can also simplify this further. You can look for numbers that are in common between 38 and 42. They're both even. So 38 divided by 2 is 19, and then 42 divided by 2 is 21. So your final answer is 19/21 if you're asked to simplify any further. Let's look at our next example. Second question is going to be 2/5 multiplied by 9/10. So we can choose to simplify first, which I am going to do. 9 and 10 have nothing in common. That's 9 and 10 have nothing in common. 9 and 5 have nothing in common. 2 and 5 have nothing in common, but 2 and 10 can both be divided by 2. So 2 divided by 2 is 1, and 10 divided by 2 is 5. That's as much as I can simplify, and then I multiply my numerators. That's 1 times 9, and my denominator, which is now 5 times 5. 1 times 9 is 9, and 5 times 5 is 25. Next example. So we have -1/8 minus 1/2. So we're essentially taking away a positive number from a negative number. We're looking, it's fractions. We look at our denominators, they're not the same, so therefore we have to find the LCM. So we're looking for multiples of 2 and then multiples of 8. So my multiples of 2 would be 2, 4, 6, 8, 10, and so forth. And my multiples of 8 will be 8, 16, 24, and so forth. And the lowest common number between both of them will be 8. So my LCM is going to be equal to 8. Great. I already have one fraction which already has a denominator of 8, so I'm not too worried about that. This fraction, 1/2, I need to change it into a fraction where my denominator is 8. What do I multiply 2 by in order to get 8? By 4. So 2 by 4 gives me 8. I multiply my numerator by 4 as well. 1 times 4 is 4. So my original equation is now -1/8 minus 4/8. And because my denominators are the same, I leave it as is and just do the operation in my numerator, which is subtraction. So I have -1 minus 4. So -1 minus 4 becomes -5. Again, this is using negative numbers. You can refresh your memory in a previous course, or again, you'll see with the set of practice problems that are at the end of this video, as in the written practice problems and solutions. So this is -5/8. Okay. Next question. So I have -2/9 divided by -28/3. It's a division question. So the first thing I do is I change my second fraction to the reciprocal. That means my denominator becomes my numerator and my numerator becomes my denominator. And I change my division sign to multiplication sign. Sorry. Right, and then I leave my first fraction as is. Now I'm going to do try and look for things that are common between each other. I have 3, there's 3 and 9. 9 and 3 both have 3 in common, as in 3 divided by 3 gives me 1, and 9 divided by 3 gives me 3. Then I'm looking at -2 and -28. They are both even numbers, which means that they can be divided by 2. So -2 divided by 2 will give me -1. And -28 divided by 2 will give me -14. And I know I have already a negative number on the top divided by a negative number gives me a positive number. Right? Because those are the rules of multiplying by negative numbers. When you multiply 2 negative numbers or you divide 2 negative numbers, you get a positive number. Right? So my numerator now reads 1 multiplied by 1, and my denominator now reads 3 multiplied by 14, and 14 times 3 is 42, so that's 1/42. And my last question, which is -3/8 multiplied by 5/6. I am looking at the numerators, 3, -3, and 6, sorry, both have 3 in common. So -3 divided by 3 will give me -1, and 6 divided by 3 will give me 2. I have nothing else that could cancel between my numerators and my denominators. 5 and 2 have nothing in common. 5 and 8 have nothing in common. So this is as simplified as I can get. And now I multiply my numerators, which is -1 times 5. My denominators, 8 times 2. A negative number by positive number is a negative number, and 1 times 5 is 5, so that's -5 on my numerator. And then 8 times 2 will be 16, so my final answer is -5/16. So that brings us to the end of our lesson, where we would have done a recap of numbers, a little recap of negative, or the idea of adding positive and adding negative numbers, and then of course a recap of our fractions with respect to addition, subtraction, multiplication, and division. This is Foundational Mathematics for Secondary School Beginner Level. This course is facilitated by Limitless Learning TT, where it's all about learning on the go. Log in to our website from any place at any time and view past videos, practice problems, and solutions for your course. For more information on the services we offer, visit www.limitlesslearningtt.com, and if you have any additional questions or concerns, please feel free to email us at info@limitlesslearningtt.com.